In our modern society, everyone needs to be scientifically literate. And this doesn't mean just knowing facts, it really means knowing how to apply the facts and ideas of science to make better decisions, decisions about one's personal life and health, in their work, and in public policy. Now, this is really a new and large educational challenge to achieve this. But fortunately, we have major advances in research on learning that are giving us guidance on how to accomplish this. This research is revealing much better ways to teach science, particularly at the university level, and particularly teaching people to make decisions using that science. And this kind of research involves doing experiments, collecting data, developing concepts, doing controlled experiments, like so we get results like shown in this graph of comparing different teaching methods. So really very much like doing more traditional areas of science. And at one level, this has really changed our whole paradigm of learning this kind of complex thinking from the old view of you've got this brain and you're filling it up with knowledge. And instead, what research is showing us is actually what's happening is uh, through educational process, when done well, you're really transforming the brain, changing the wiring in there to giving it new capabilities to make these better decisions. And in this process, it's also established expertise, a set of practices and principles that, when known and implemented, consistently produce better learning across many, many different studies. And this shows there's lots of features, all these different boxes contain areas of research that are part of this, but together they really give you the idea of how to properly design and implement educational activities to produce greater learning. So how do we move this? How do we take this research and put it into practice? Much like medicine faced in the 1900s of going from a folk art that any individual sort of did what they felt worked to a skilled profession. And I like to think of it as we're really trying to make a large scale shift from the pedagogical equivalent of bloodletting to use of antibiotics, what research tells us works. So I led a big experiment at University of British Columbia on trying to do this, try to change the teaching across many science departments there, and discuss the details in a book. But the basic elements of this are we had substantial competitive grants to departments that really provided them then with the individual level with incentives and teaching staff development in these teaching methods in use in their disciplines. And some of the most important results is first, we showed it was possible. We changed entire departments, how they taught, and hundreds of courses and teaching staff, and ended up, though, with the same cost, just much better results in learning. We found that when faculty learned to teach this way, it took some time, but they actually preferred it, enjoyed it more. But it was essential that at the department and the higher administration level to recognize and support this idea of teaching expertise. And the bottom line was they really had to find better ways to evaluate teaching, better ways than in practice now, so that they can measure and reward expertise. Thank you.
Well, thank you very much indeed, Carl. And now for the discussion on teaching science. I'm happy to be joined by two further Nobel laureates and teachers of science, Ben Feringa and Donna Strickland, both of whom you've met earlier in the day. Having heard Carl's talk, Ben, let's start with you. Have you any reflections?
Yeah, I'm not sure if I fully grasp what is meant by teaching science as folk art, which was just mentioned, but definitely, teaching not only facts, but thinking in terms of concepts, and what does fact means, and analyzing that. And that is, I think, a very important message, and we should strongly advocate that. It is about how to learn how to use things, what is the value of information, the quality of information, and try to translate that in concepts, principles that you can apply to different problems. I think that is essential.
Mm-hmm. In the current environment where so much teaching is having to be done online, do you think that the sort of approach that's talked about where you really have to get to grips with the problems is easier or more difficult?
No, it's way more difficult. I have the experience now because at the moment I'm teaching also. And I must say that I'm in the natural sciences, and their experiments are extremely important, of course. We train with our students to go through the process of discovery. And I think it is so important there. And for instance, when you teach only via the internet, it's extremely difficult to have practical courses to do this kind of discovery, etc. So I think we have to do something there to change it. For instance, to make programs where the students learn more this practice of using information and then go through a problem step by step and get this feeling of discovery. I think that is really important. And to do experiments, either in the lab, but if that's not possible, do the experiments via, for instance, computer games, other ways. I think there are great programs that we could make to get them engaged in this whole scene of doing experiments and discovery.
Mm. It's nice that you use this word of discovery, because I suppose everything one learns in any teaching course is a personal discovery, and it's not always portrayed in that way. It's not just a fact.
No, but you have to be you have to be very careful there, because if it's just a summary of facts, it is not what you want to teach or what you want to engage with your students. You want to get with them in this adventure of learning how to use facts, how to go to make the steps, also to make mistakes, that you go into a route where it goes wrong, and that you suddenly realize, oh, I did a misinterpretation. I have to go, instead of to the left, I have to go to the right. I think this is important for education.
Thank you. Donna, please.
Well, first, I'm happy that Carl mentioned the University of British Columbia, because I sort of got involved in this a little bit, being in charge of our undergraduate labs and redeveloping them using these teaching principles. And one of the, I think, first PhD grads from the program that I think Carl started at UBC is Natasha Holmes. And she's now at Cornell. And so I took a trip to Cornell. It's easier than going to BC from where I am. And we are trying to redo our labs. And then, of course, COVID hit. But, there has been some thought put into that. And so we've sent little kits to each of the students. And as already been said by Ben, it's about getting the students to ask the questions. It's getting the students to wonder why. That is what science is about, right? And so I've also heard, in teaching, it was always just 5% the professor, 95% the student. But in the traditional lecturing, maybe we professors started to think it was 95% us and 5% them. And so, it's how to get the students to go, oh, I have to wonder why. I have to ask why. Yeah. And so we are still doing little labs at home. And then they have to decide if it's a good experiment. So it used to be that we thought, oh, experiments are all about just reinforcing teaching physics concepts. And this education, or the research into the teaching that Carl talked about, is really showing that didn't work. That what we thought we were doing with the labs wasn't doing what we thought it was at all. And so why not? The lab should be about, what does it mean to be an experimentalist? Why shouldn't they be thinking about, oh, if this is the question, what would make a good experiment? And I think a lot of
Sorry, carry on, please. Carry on.
Well, I was just going to say, first year physics is still mechanics, first term, so we always start with the whole, box going down a ramp. So you don't even have to send a kit. Pretty much everybody has some piece of flat thing and something they can slide down their ramp if they want to, and start asking, what's a good experiment to determine something.
And how keen are the students to take on this approach? Do they like it, or do they worry about the fact that it's harder to be self-generating? Carl, please.
So, I mean, this is something that my group, and particularly led by Natasha Holmes, who's worked with me, that Donna's mentioned, has studied quite a lot in the introductory labs. And we find that this giving students some autonomy, some independence, uh, they like it much, much better. They find it much more rewarding, because otherwise it seems like they're just following recipes, which of course is boring. So this idea that to elaborate on what Donna's talked about is when we actually study in detail, kind of not just both how the students are engaged and what they're enjoying, but also what the thinking they're doing. This idea of leading them up to decisions about the experiment. Can they interpret this data? What can they conclude? How could it be going wrong? Leading them up to, but not telling them. They have to make those decisions and then see what that means. That's both very powerfully motivationally and cognitively in terms of the actions. So I'm just using different words, but saying much the same as Ben and Donna are saying, but we just studied this in a lot of detail.
Thank you. Donna, sorry, you wanted to come in and then Ben. Yeah, Donna.
Well, I just want to follow what Carl said, because also a big part of it, and when I visited the labs at Cornell, what was great is there was huge discussion. There would be groups of 3. And there usually is when you do labs, but they used to, in the old-fashioned way, be following sort of a cookie-cutter recipe, and you didn't see discussion. Whereas now, when you're leaving it up to them, again, it's more like doing real science. It should be a conversation. There should be a give and take and learning from each other. And you just see the students really doing that. And I think that's true even in the new ways they're doing the classroom teaching. It's about getting students to talk to each other, teach each other, try to see if you can figure it out. And again, that's how scientists really work.
Ben.
Yeah, I fully agree. I strongly advocate also to start early with small research projects. And you have to, at the undergraduate level, of course, you have to balance it with the techniques and what you know. But I think it stimulates students enormously, and that's my experience. If you get them involved in these tiny research projects where they can think themselves, they have this level of autonomy, what was just mentioned. And I think working in small groups where they encourage each other and criticize each other and ask questions. And I think this working together is also reflected what will happen in real life later. When they become advanced students, when they come in a research environment, they have to work in teams. They have to work with people with different backgrounds. Many of the projects we do in research, real life research laboratories is, of course, with different expertises and so on. People talk with students from different backgrounds and different levels. And I think if you start early with that, it gives them this spirit and enthusiasm why science and education is so nice.
Carl, we're almost out of time, but just to finish with you, please.
Yeah, so I just want to take this back to the online. I mean, the point Ben makes, you can understand why it's much more challenging to have these things happen online. But what it means is to be effective in the teaching, one has to be much more intentional about setting up ways for students to interact and talk to each other in the online environment.
Well, thank you all very much indeed. We've been focusing quite a lot on lifelong learning throughout the day. And I wish I could join labs with any of you. It sounds such fun. So thank you very much indeed. It's an inspirational panel. Thank you.